Good day, ladies and gentlemen. I welcome you all to Chito's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you should kindly subscribe to my YouTube channel. Click on the subscribe button, hit on the bell to get the notifications anytime I drop my new content. So now today we are going to be looking at the nature of roots of quadratic equation. So now, what do I mean by nature of roots of quadratic equation? That is, how will your root of the quadratic equation will look like. So let's see, having the solution of ax squared plus bx plus c equals to 0 to be x equals to this. Here we all know that because solving this general equation by completing the square method will lead us to this quadratic formula. Are you getting it? So therefore x, these are the roots of this. You understand? So now if you now want to determine what will be the value of your variable x, understand, how will it look like, understand, which plane would your your solution, your roots will be, understand. So that is what we are going to be looking at here. So from this equation, so we now have what we call discriminant b equals to b squared minus 4ac. So it is denoted by this sign. So this is called discriminant. Understand? It's like the soul of quadratic equation, because it is only it's only one that you can, it's the one that you look at, you understand, to before you can determine the nature of the root. Understand? So that's why I call it the soul of this equation. So now we have this. So if this one is now equals to, that is, our discriminant to be b squared minus 4ac is greater than 0. So the nature of this will be, that is, the nature of that particular equation, so will be real and what, and different. So we call real and different, or what, or distinct. So at times they use distinct. So that will be the roots of the nature of the roots when this is happening. So the second one is if this is, that is, b squared minus 4ac is equals to 0, that is, this will be real and what, and equal roots. Understand? That is, you can say that the two possible values of x, or the variable we used from the equation, will be what, will be real, and at the same time will be what, will be equal. Understand? That's what I'm saying. So they have to be equal. So if you have this with 0, so the third one is if you have a, that is, the discriminant to be b squared minus 4ac now less than 0. Understand? So this will be complex root. So that will be the, so what is complex root? You can have your x to be a plus ib. Understand? In this form. So this is complex. You can see because of this I. Understand? This is how you'll be getting your value. Can you see that? So this is what you can be getting your value. That is, this will be actually less than 0. So now, that is, if we now say greater than 0, understand, the same thing as positive, that is greater than 0. Therefore, when this is what is positive, that you have what, you have real and distinct. When it is equals to 0, we have real and equal roots, and when it is less than 0, we have what, we have complex roots and something in this form. Are you getting it now? So these are the things. So I will like you to have this one, you understand, to jot this one down, so that we will be following this anytime you want to, maybe you are given a problem to determine, or you are given a quadratic equation, so to determine their roots, understand how the root will be. So this is what we are going to use, understand. So I want you to put this down on your notes. I get it at the same time. So while solving the problem given to us, so we'll be able to be following and understand. You understand? So now we can now go further to solve the problems we have on the board. So now, having this problem, they said determine the nature of the roots of the following equations. So we are going to look at this, understand, then we follow by using our discriminant, that is b squared minus 4ac. Understand? So what are we going to do? Where can we get our b? What can we get a? Where can we get c? Understand? We are going to get the values from here by comparing this, that is a. Let's say we have 2x squared minus x minus 1 equals to 0. If you remember, you can see that the general form of equation of quadratic is ax squared plus bx plus c equals to 0. So now to get a, b, c, now you understand, so we are going to compare the coefficient of x squared, the coefficient of x, and what we compare the constant term also, and at the same time we have 0. So I think we are given something like this: 2x squared minus x then minus equals to 1, like this. You understand? So determine the nature of this equation. Actually, this is quadratic equation, but you need to take this one back to the form of general quadratic. You understand? So now the form of general quadratic is you take this one back to this side where you'll be having 0 at the right hand side, so it will look the same as what we have up here. So now, so if you have this one now, understand, so you can see that to compare this and this, we have our a to be 2. To compare this with this, you can see that b equals to minus 1. Then to compare the constant term, that is the one that is not attached to x, so therefore we have c to be minus 1. So anytime you have minus, so you need to take note of that. Understand? Therefore we are taking the negative with what? With the number. That is, let's say if you have plus here, you can actually say your c is 1 because what we have is positive. Are you getting it? But since it is negative, we have negative here, definitely you'll be taking the value, the number with what? With the negative sign. So now we have that. So now consider that we have a, we have b, we have c now. So now you now use our determinants, that is the discriminant, sorry. So that is, what is our b from this equation? B is what? Is minus 1. We have minus 1 all squared minus 4 is constant already. Then what is our a? A is 2. We have 2. What is what? What is c? We have c to be what? 2 to be minus 1. So if you try to solve this one further, minus 1 squared, we have 1. That is minus 1 is the same time minus 1 times minus 1. Minus times minus, we have plus. So 1 times 1, we have 1. So 1. Then 4 times minus times 2 times this. You can see minus times minus will actually give us plus. 4 times 2, 8. 8 times 1, we have what? We have 8. So we have what? We have 9. Can you see what is the result of this? You can see that we have d to be what? To be 9. Can you see that? Where 9 is what? Is greater than 0. When you say this is greater than 0 or x is greater than 0, it means the value of x is what? Is more than 0, is beyond 0. You understand? So start from 1, 2, 3, 4, 5 and so on like that. So you can see that d is greater than 0. So you now conclude that the root of what? It means that this equation is having what? Is having the, what's it called? The root to be distinct, that is real, and what? And distinct, or what? Or different. So that is the nature of the root for this what? For this one. Are you getting what I'm doing there? So now the second one. So if you now try to solve this, are you getting it? So you see that the solution, the root you are going to get will be what? Will be real and distinct. So they will be real numbers, and at the same time these roots will be different. And also the second one, if you are to take this one, you have 4x squared minus 12x plus 9 equals to 0. You can see that you don't need problem here. You don't need to transform it to general form already, because it is already in general form, because the right hand side is what is equals to 0. So you can compare with this. So now comparing this with that, so we have our a to be 4. Can you see? We have our b to be what? B to be minus 12. Then we have c to be what? We have c to be minus 1. So from there, we now bring our discriminant, that is b squared minus 4ac. So now we put this value, we have already our b to be what? Minus 12 all squared minus 4. 4 is there, multiply by, what is my a? A is what? A is 4 also. Then multiply by, what is c? C is, oh sorry, my c is, mistaking it. So my c is what? Is 9 here. So I have what? I have 9 here. If you look at this, you see that our discriminant, this will be 144. If you multiply this times this times this, will actually give you 144. Understand? So we can see that this is now equals to 0. So now for this to be equals to 0, are you getting it? For our discriminant to be equals to 0, definitely the solution or the root of these equations will be the same. That is, will be real and equal roots. So we have what? We have this solution to have what? To have real and equal what? Equal roots. You understand? So that is what? That is the nature of this one. If you found your discriminant to be what? To be 0. So the last one we are going to solve sheets. The last one we have 2x squared plus x plus 3 equals to 0. So this is the last one. So the last one we are going to solve. The last one we are going to solve. So let me try to write it back here. Plus x plus 3 equals to 0. So that I can have space here. Yeah, I can write. So now from here, so you can see this one also is already in this what? In this form. Or let me try to change it. Let me say I have this equals to 3. Let me have it like that. Or minus 3. Let me say minus 3. You can see that to determine the nature of this root, the first thing you are going to do is to transform or change this to be in what? In general form of quadratic. So changing this one, so this could be written as 2x squared plus x. So take this minus 3 to this area, plus 3 equals to 0. So which is now in the form of quadratic equation. So now by comparing, so we can see that our a is 2, b is 1, and then c is 3. All these ones are positive. That is the reason why we are not even consider the positive sign by writing the positive here. So now we now take the discriminant, that is b squared minus 4ac. You can see. So now for d, what is b squared? B squared, what are b? We have 1 squared minus 4 into bracket. So a, don't be confused, I'm using multiplication here. If you like, you can still use bracket. It's all the same thing. So minus 4 times, what is my a? My a is 2. Then multiply by, what my c? C is 3. Can you see that? So from there, you can have my discriminants to be 1 squared to be 1. Then minus 4 times 2, that is 8. You understand? Then 8 times 3. 8 times 3 give us what? Give us 20. 8 times 3 give us what? 24. Are you getting it? So 1 square will give us 1. 4 times 2, 8. 8 times 3 give us 24. You can see that I have my discriminant to be what? 1 minus 24, we have minus 23. Can you see that? So, and what is minus 23? D is minus 23. It shows that D, that is the discriminant, is what? Is less than what? Is less than 0. Can you see that? That is what is negative. So when it is negative, it means negative. Understand? Why this means what? Positive. When you say positive means it's greater than 0. Then when you say negative, that is this is what is negative, is because is what is greater than 0. Is less than 0. Can you see? This discriminant is minus 23, which is what? Which is less than 0. Therefore, it is negative. So therefore, so we now conclude that this root has the nature of the roots of this particular equation will be complex roots. Understand? The complex roots, where you'll be having something like maybe your x to be ai, understand, or bi. You can see the I now attached to it, to the real. So which is what? Which is now a complex, changing, understand, to complex plane entirely. So that is that about the nature of roots of quadratic equation. Understand? So you don't need to solve problems, anything. If they ask you to check the nature or to determine the nature of quadratic equation, you don't need to be solving by factorization, or you solve by complete square method, or you solve by quadratic formula before you could know the nature of the root. So this is the step you follow. You use what? Discriminant. So that is the end of today's lecture. Kindly subscribe to my YouTube channel. Hit on the bell to get the notifications anytime I drop my new content. Have a beautiful day ahead.